Okay, next lesson is on hydroelectric power, and this is the power that we get from water. And it's usually from our rivers and dams that we build. Okay, how does it all work? Well, if we go here, a hydroelectric plant depends on building a dam, and you have to build the dam in very specific locations where you have very steep river valleys that can really pile up the water behind the dam. And that's one of the keys that we got going for us here, that we really need to get this water piled up as high as possible. So you build a dam, all right, as high as you can, and then it's very simple. As the water backs up behind it, you allow opening for water to come through, and that water now can move at a high rate of speed down an opening where it turns a turbine. That turbine then is connected to a generator, which then creates the electricity, which is then sent off. All right, and then the water can continue down and continue flowing downstream. So the goal is to make this water back up, hold back, go down through the dam, and when it goes through the dam, it can have a tremendous amount of speed, which can turn a large turbine and make a turbine spin and generate electricity for the world. The goal, though, is to get those much water force through as possible. So how do you do that? Well, you have to think about it as energy transformations. Okay? And we're going to look at it through the idea of two types of energy, which you've all heard of before, hopefully, and that is kinetic and potential energy. All right, and for you physics people, you should know the formulas for each of these. Kinetic energy is one half the mass times the velocity squared, and for potential energy, it's mass times acceleration due to gravity times the height. Okay, so the goal is to make the turbine spin, meaning to create as much kinetic energy as possible. And in order to do that, we have to take the potential energy that's in that water, convert it into kinetic energy, as in moving water, and then eventually transfer that kinetic energy into electrical energy, all right, for electricity. So, how can we make a large amount of energy in a dam? And that goes back to the potential energy formula. Potential energy is based upon the mass times acceleration due to gravity, all right, times the height. And this is why, and this is the explanation why we build dams the way we do. Because in order to get enough kinetic energy to create the electrical energy, you need maximum amount of potential energy. And that potential energy is going to come from the mass of the water. So if you can build a dam that's going to hold back a huge amount of water, and then, since G is a constant, then raise it as high as you possibly can, you're going to create the maximum amount of potential energy. And if you get the maximum amount of potential energy, the stored energy in that water, it's going to be converted into the moving energy of motion called kinetic, which will then convert into the maximum amount of electrical energy. So the goal of a dam is to create the highest amount of potential energy in that water. So you need to create a massive amount of water behind a very high dam. And that's how the hydroelectric power works. So it's good, simple explanation, all right, and hopefully one that you can understand. So we have some dams that are out there that do this. One is the Hoover Dam, which you've probably heard of before. It serves the states of Arizona, Nevada, and Southern California. It's massive. It only cost $49 million to make initially. Today, the cost would be far more. These dams are super expensive to build, which is one of the downfalls with hydroelectric. But it does create over 4 billion kilowatt hours of electricity per year, and that's substantial. And what you see here in this picture are one of the turbines. So as the water falls through the dam, it's going to go through the pipe you see in the middle, and above it is the turbine, which is going to be spinning, which is connected to the generator, which makes the electricity. But if you want to talk about a dam on a large scale, In fact, the largest in the world, the largest hydroelectric dam in the world, and that is what you see here. This is called the Three Gorges Dam. And the Three Gorges Dam is in China. It is the world's largest hydroelectric power plant, and it's also the largest concrete structure in the world. And it's very hard for you to get a picture of how big this really is. We can see the picture over here of the Three Gorges Dam, but to give you some perspective, if you see these little sprays, kind of hard to draw with my white pen, but real quickly, these little sprays down here, if you see those sprays, that is what you're seeing here in this picture. All right, you're talking massive amounts of water going through. The Three Gorges Dam is over 600 feet tall, and it is created, and it's supposed to be supplying lots of the parts of China with electricity. Massive amount of problems with this dam. In fact, most people told them not to build it, but they went ahead and built it anyway. And there's massive problems, which we're going to get into when we get into water unit. But right now, we're just dealing with electricity. This map is a wonderful map to look at because it shows you where in the United States all of our dams are located. Okay, and it's very difficult to see, but these are all hydroelectric power plants throughout the United States. And you can see that we pretty much have taken up every single possible location where we can build a hydroelectric plant or put a dam. So to see hydroelectric as a large increase or the ability to supply us with our electrical needs in the future, it's just not there. We pretty much maximize hydroelectric at this point. Now there are other types of hydroelectric power that you can create. Run of the river is kind of an interesting possible idea, and that is where you have smaller rivers, especially in where there's a rapids or a waterfall or something. You can create a diversion through a pipe, and that diversion, then you could put a small turbine on, and you can create a small amount of electricity, which is helpful, but it's not producing electricity on a large scale like you really want. The other possibility is looking into tidal power. Now, tidal power is an interesting concept with hydroelectric. The problem is it is super expensive to make, and it's not going to be utilized until our electrical needs are just so great that we're willing to spend huge amounts of money. But it is a promising idea where tides that come in and out, or especially out of bays, okay, and coves and stuff, we could actually trap that water, hold it, and then as it releases, use it to spin turbines. Okay, so in this particular diagram, I think you can get the idea. There's two ways you can do it. In this particular one, you have a turbine in a tube which is anchored into the bottom. So as the tide comes in, it spins the turbine as the high tide comes in, and then when the tide goes out, all right, it'll spin the turbine again. This is going to be a small amount of electricity, a small amount of turning, but it can produce a fair amount of electricity. But it is expensive. The other possibility, which you can take a cove or a bay and put a dam across it, which is the bottom diagram we have down here. Sorry, let me get a slightly better. Give me a second here. Let's see. We'll go with a nice blue. Where you build a dam, cross a cove or a bay. All right, like you see here. And then what you do is when it's low tide going to high tide, the water can rush through your dam onto the other side. So as the high tide comes in, the water goes through your dam. Okay, and then when you reach high tide, you block these holes, basically, and you hold the water back. So a high tide level of water is up in this range. Then you wait for low tide to occur, which is down at this range. And look what you just did. You created height. And the nice thing about it, since the entire ocean goes through this tide, you have a very, very large mass of water back here. So the potential energy which equals mass times gravity times the height. You're increasing the mass because you have large amounts of water, and you have some height there. So you have some potential for energy. Then once you get maximum high tide, and wait until the tide is as low as possible, when that happens, you open up these holes, allow the water to go through and spin the turbines as the water rushes out back into the ocean during low tide. So you have that possibility too. Again, these are expensive alternatives, difficult ones. The technology isn't completely there. Okay, the pros and cons. What's good, what's bad about hydroelectricity? There are some real benefits, and when I look at it, one of the main benefits, obviously, is the fact that there's absolutely no pollution. It's clean power, it's renewable, it's always there. But that's not just the great benefit of hydroelectric. Some other things. It supplies water. In case of a drought, it can hold water in the lake in case we need it, in a reservoir in case you need it in the future. It can control flooding. It's a simple design that costs very little to maintain, and the great thing is it also lasts quite a long time. And an interesting one is that it can be shut down instantly and restarted instantly. That can happen when you have coal burning or natural gas burning power plants or nuclear power plants. They can't just shut down and restart. Okay? So it basically has very few issues. But the problem is those issues that do arise are very few, but very disruptive. Okay? And that is that it disrupts an ecosystem because both upstream and downstream from the dam, you're going to alter the ecosystem. Upstream, you're flooding it, creating a large reservoir, all right, which is going to be flooding huge amounts of ecosystem along the river. Second, after it goes down through your stream, you're now disrupting the flow of the river downstream, which is going to alter the ecosystem. And we've tried many, many times to try to minimize that disruption as much as possible. And we're having some success, but most of the time, failure. The other thing which you don't hear much about is the idea of salmon. Okay, if you remember the salmon runs where the females have to lay their eggs up in the initial streams, way up in the back of the rivers, when you have to go up through the river system. Well, if you put dams on a river, you basically are blocking the migration of the salmon. Okay, from the ocean, they have to make it all the way up to the small little streams and stuff up in the mountains, and they can't get there, so you're disrupting the life cycle of the salmon. Therefore, we see the populations declining drastically. The other problem is there's a huge initial cost. Dams are very, very expensive. The Three Gorges Dam in China, although nobody really knows it, they estimate somewhere between $30 and $60 billion to build that one dam. Also, drought could affect performance. As you lower the water level in the dam, you know that it's not going to produce as much energy because there won't be as much potential energy there. So you do have that problem. And probably one of the most significant things for us here in the United States is there's very few, if any, viable locations for us to put it. Okay? So that pretty much does it for hydroelectric. Possibility to continue to supply us with electricity, but not going to be increasing in any large quantities anytime in the near future. So once you get all that figured out, you now have it, and you are now an expert in hydropower.